I'm a repeat speaker in this forum. Thanks for the wonderful folks of Devon for letting me back. Theory without practice is empty, and practice without theory is blind. This strongly resonates with my belief system and what I have seen in my career of 2.5 decades. I write on Medium, so if any of you are interested, that's a place where you can tap into more of my ideas, and that's my LinkedIn profile. Disclaimer, some of the pictures in this slide deck are from Google searches. I'll start this talk with a few anecdotes from my professional career. One of my previous employers was using a monolith, and the build used to take like multiple of hours, 5 to 6 hours. And it's not like you start and go away, but you have to monitor, things might go wrong, you have to go back and do this. The employer had about, I guess 15,000 engineers on their payroll. And they still thought it was okay to waste like 6 hours every month or so, every 2 weeks. This is one example of using a bad example of using a monolith. A different employer, I saw a microservice which had one method, and that one method was invoking a JDK API and returning the response. There was absolutely no need of making a call over the internet to call what was a Java library. This is another example where mindless application of microservice was counterproductive. The third anecdote is I had recently. A friend of mine, he joined a startup, and he spoke about how they have microservices, they have deep copies everywhere, and he felt that the entire software could fit into one powerful machine and didn't require microservices. So there are reasons to employ microservices. There are reasons to not employ microservices. This talk kind of gives my perspective at a high level, what I think. System theory is a branch of science which talks about how complex systems are built. I take inspiration from system theory in this TED talk. At a high level, a system is a group of interacting or interrelated parts which work together to form a unified whole. A system is described by its boundaries, structures, purpose, and purpose. So this is a software engineer's representation of systems. A system can have multiple parts. A part can be an element, or a part can be a system itself. I'll repeat some of these things from my earlier TED talks. Consider a road like this. There is hardly any traffic, but the road is not uniform. There are ad hoc entry points, it is not uniform height, width, and so on. This road is irritating, but it's okay to drive. Compare this. There is a lot more uniformity and not many vehicles. This compared to this would be an easier driving experience. Now this is specimen 3. There are a lot more vehicles on the road, but there are clear do's and don'ts when you change lanes, when you take turns, and so on. And this is our good destination. Bangalore traffic. There are many vehicles. There is hardly any rule that people follow. They turn wherever, the road is not uniform. There's a lot of ad hocness. You can categorize these 4 specimens into this 2 by 2 grid. There was a non-uniform road with few vehicles. There was a uniform road with few vehicles. There was many vehicles, but there was order. There were many vehicles, but there was no order. So I name these the irritating, simple, complex, and complicated. Between when only few vehicles, we would prefer 1 over 2. But if we had a lot of vehicles, we would prefer A over B. Agree, disagree, comments? If you map it to software systems, these map to 2 different dimensions. How modular the systems are and how complex the systems are. Now, the number of vehicles on the road is not something we can control. So, that is an extrinsic property. Whether the road system is structured or not is a deliberate activity. Okay, there are a couple of foodies in here. So you might have known this choice. Food can be good, fast or cheap. Of these 3 dimensions, you can have at most 2. What would each of you pick? Or some of you pick?
Depends on the situation. It could depends on the situation.
Okay. Well, I am a foodie. For me, the goodness is not negotiable. So, I want my food to be good. Then I trade off between if the food is fast or cheap. So, 2 out of 3 is one perspective. I want my food to be good, then I choose my food to be fast or cheap is a second perspective which I hold. The reason I am mentioning this, I want to draw a parallel. Modularity for software system is a must as per me. Whether the system is distributed or not is a orthogonal choice, but the fact that the requirement of modularity is non-negotiable for me in vast majority of software development scenarios. We throw the word microservices with lot of loose connotations, and that people have different interpretations. I want to make this slide should convey my view of software. You can have a single process, or you can have multiple processes. You can be modular or not modular. You can have a single process and not be modular. This is pejoratively called the ball of money. You can be modular and have a single process. This is called the modular monolith. You can be modular and have multiple services. This is what I and some people call microservices. You can have many processes and still be not modular. This is called the distributed ball of mud. By moving to a distributed architecture without modularity is like putting fertilizer to weeds. You magnify the problems you have. Yes, please.
When you say modular, based on the business functionality or technical aspect or both?
I will come to it.
Also, it was difficult to understand the ball of mud concept.
The ball of mud is, there is no clear way to navigate it. It is chaotic, unstructured, disordered. There is no clear, you can't understand, there are no abstractions, there are no layers. Those things is what I call. Lack of modularity makes something a ball of mud. What is a distributed system? A very simple definition. Part or part of the system run in different processes, possibly on different machines. So, my first recommendation is, I repeat my 45 years, the system should be modular, and then you have a choices of making it distributed or not. Modularity speaks about part and system part relation. This is the criteria to define modularity. It is from a wonderful book called Object-Oriented Software Construction. I highly recommend you guys read it. It may take you a few years, if not a decade, to complete the book, but it's a good book to read. The criteria are decomposability, composability, understandability, continuity, and protection. As engineers, we have a natural intuition to decompose systems, so I'm not going to spend too much on that. But a modular system can be broken down into parts which can be combined in a different configuration to yield a different configuration or a different set. Continuity is a oft ignored and not a well understood problem. A continuous function is one where a small change in input causes a small change in output. If a small change in input causes a large change in output, such a function is not continuous. In the context of software development, if a small change in requirements results in massive redesign and a massive work, such a system is not considered to be a continuous system. So a modular system is a continuous system. Changes in one part of a system should have no or minimal effects on other part of the system. This is a concept of protection. The book speaks about how to accomplish modularity. Couple of things I want to highlight are few interfaces, narrow interfaces, explicit interfaces, and information hiding. Folks, information hiding has multiple connotations. One is hiding information from code. If you make something private, or other part of the system may not be able to look at it. But there is another part of information hiding which is largely ignored. How many of you use AWS? Do you know what happens under the code generated AWS? large part of it is unknown. You can operate without assuming what happens underneath the hood of AWS. This is information hiding from humans. AWS, by having clear interfaces, they are able to hide information while still being consumable to their consumers. The reason I mention this is, we look at code of other systems or other libraries, understand their details and start reading. This is a double-edged sword and often can lead to slightly non-modular code. I will not go deeper into this. Java interfaces like in Java are a bunch of methods. They define some types. They're a requisite part of contracts, but there's more to contracts. There's a distinction between interfaces and contracts. I wanted to think in terms of contracts. Folks, these are well-established fallacies to distributed computing. Network is reliable, latency is zero, blah, blah, blah. Thankfully, because of advances in infrastructural software and systems, the 4 of these 8 have been handled by these systems. That leaves us with 4. Network is not reliable. The latency is not zero. Bandwidth is not infinite, and there is transportation cost. These are realities which are somehow ignored by programmers. This is information we copied from the internet. Between in-memory representation and in-memory access to accessing something over the network, there is an order of magnitude increase in latency. Programming in a monolith or in a non-distributed manner, we tend to focus on the business scenarios and business failures, if any. But the moment we go to a distributed world, there are a class of problems which are not present in in-memory or in-process scenarios. There are crash failures, there are timing failures, omission failures, and budgeting failures. We have to deal with lost messages, incomplete messages, duplicate messages, out of order, partial failures. I want to talk about 2 well-known failures. There was this trading company, stock trading company, where a developer chose to repurpose an old flag. He deployed the code. The code got to all but one machine. One machine had new code but some old configuration. This resulted in the code placing some bad traits. The company lost about $460 million in 45 minutes and went bankrupt. This is an example of failures. Probability is non-trivial. There have been scenarios where it has come back and bit people in a big way. Another example is Uber Eats, where Uber assumed some API to be idempotent. The downstream API was idempotent and it became non-idempotent because of the developer not thinking through something. And this resulted in a bug balance is 0, it would still place order. And somebody observed this, put it on internet, and everybody started placing orders and got food for free. So problems tend to magnify at scale. So as developers, we need to keep an eye out for problems with this program. There are many dimensions of within software unity concept. I focus on what I think are the key part. Business brings in set of invariants, complications, legacy, non-functional requirements. Then developers bring in the set of challenges. Developers, managers, product management. Then there is technology has its own set of challenges. Time has a set of manifestations. Money has its set of manifestations. In the subsequent slides, I talk about pros and cons of distributed computing in the context of these dimensions. Is anybody familiar with domain-driven design?
For multi-tenancy.
So domain-driven design is a domain-centric view of software development where we break down the problem into subdomains and possibly multiple bounded contexts for each subdomain. This is a way of decomposing your software. Another emerging area or emerging view is of volatility-based decomposition. Folks, in terms of your software, besides method, object, and microservice, what makes up a vocabulary of a common developer?
Why do you put them on the same plane?
These are the abstractions we think of.
Would we think object and methods at the same plane as a microservice?
No, they're not same plane, they're a continuum. One end is a method, more granular is object, then you can have a package, but have a microservice.
Okay, so that's in the increasing order of...
Yes, that's what I'm trying to write. Do you have any other abstractions there?
Entity or
That would map to approximate object.
Bounded context?
Yes, but it is not enforceable via code. So, folks, one of the key reason to apply services and distributed computing is this concept of a bounded context or a subdomain. We can concretize by making it a separate jar, deployable file or whatnot. So this provides a vocabulary and a method of reasoning for various players. So, moment we go further from the level of objects and classes, we can think of subdomains, bounded context, and context map. Who's familiar with the Conway's law?
I see mentioning Congress law in multiple presentations. I see mentioning this law in multiple presentations in our articles.
Yes. So Conway's law tells us that how designers and software developers are structured or how they communicate maps to how the software is designed.
The state of the enterprise, the way org structure is designed,
Yes.
the systems transpose.
The shape of communication structure maps to the shape of the software. Now that shape might be based upon org structure or not.
So, are you saying this is still relevant?
Of course.
Where? So, when you, okay, can I take a
Please, please.
So, your conversation is starting with, contrasting monoliths and microservices
Yes.
and a flavor of distributed system bringing people, right?
But when you branch out into triple D like domain-driven design and ways of decomposition, they can apply to either microservices or monoliths.
Yes.
Right? Conway's law used to be popular and true to some extent for large enterprises. Maybe it still is, but there's extremely high, ways of challenging it. Nowadays, when you look at more lean organizations, younger companies, smaller companies, platform-centric companies, the whole idea of platform and product engineering kind of contradicts with this.
No, I'm saying it does not contradict because your org structure, like you mentioned, would be divided into a platform team and maybe an application team. When you divide your team, or hear me, when you divide your team based upon microservices, the intra-microservice communication, the teams within the same microservice, they communicate more than communicating between microservices.
What I'm trying to say is that this holds good truth when you have a domain-specific setup, when you have ERPs, when you have business systems applications. But when you are designing platforms and systems, the reverse has started to happen. People shape and reshape their organizations depending on how they are building their software.
Yes, that is still Conway's law holding good. You have the platform team under one manager or one management chain. They communicate frequently. When you start dividing your teams such that their team boundaries align with microservices, you are having Conway's law work for you.
I kind of agree to disagree because I'm currently where I am. We had exactly when I joined, one of my core challenges was that the way you have shaped your tech and systems are very much in line with your org strategy. But what they now did is they are going through a transformation and realizing what core products they need, what platforms they need, basis what the consumption behaviors are of the business,
Yes.
and then reshaping it.
Hold on. Domain-driven design-based decomposition need not be compatible with the volatility-based decomposition.
What I'm saying is it's not domain-driven. Domain-driven holds true when you have a banking system, when you have insurance. But when you are building let's take core technology products. Triple D doesn't have a very strong influence when you are building platforms.
I'm not promoting one way or the other. I'm saying these are different ways of decomposition. But anyway you make a decomposition, if you align your team around with those boundaries, you make Conway's law work for you.
Okay, can you go back to the slide? We'll probably take the last slide. No, the triple D slide. When you have so when you have triple D and volatility based decomposition, these are only business driven ways of doing decomposition. There are other ways of decomposition which are not business driven.
Yes.
Right? It could be completely technology based decomposition where I don't bring all of these into it.
Yes.
Okay. So are you covering them in the future?
Look, there's too much to cover in Look, at the risk of oversimplification, the way you divide your teams should be similar to the way you divide your software. If you do it, you have a higher and better way of, more efficient way of building software. That is a takeaway from these set of slides. Now, the moment you break down the system into multiple parts, you will realize that different parts of your system, some of them focus on analytics, some of them on security, some of them on compliance. This is more in sync with what you are saying. It does not need not be domain driven, but you can have different ways of yes.
So this is each domain might have its own take on security, take on compliance.
Yes.
So this is what I was trying to say.
I mean, it is the reason why I had more than one way of decomposing software. Okay. Folks, I was part of Flipkart, where the e-commerce company which had ability to check out order management, and we had software for running delivery hubs. If there is too much traffic and you're having trouble, the checkout system is overloaded. If you expect the delivery hub portal to be non-functional, it is a bad design. So by distributing software, you are providing better fault isolation. A couple of takeaways. Wherever I mark things as in the green, they represent the positive effects of distributedness. Wherever it is red, it talks about disadvantages of distribution.
What do you mean by non-functional? What do you mean by non-functional? Delivery hub being non-functional?
No, there is a portal.
Yeah.
But there's a delivery house where people pick up your packages, shipments, and load. If there's too much load on the Flipkart portal, if you expect the delivery hub portal to be down,
Yeah.
it is a wrong design. You're isolating faults. Yeah, different parts of your system can have different NFRs. By distributing them into separate processes, this different NFRs become a first-class construct in the minds of engineers. Going back, now moving to the next dimension, time. Building monoliths tends to take significantly more time. I gave an example earlier in my talk. But I also had a slide where I presented the latency of within process communication and inter-process communication. The response time shoots up by a few orders of magnitude. Yeah. Going back to Amazon AWS provides multiple machine types. So if you have different parts of the software, some of them are compute intensive, some of them are data intensive, some of them are network intensive. You can use different machine types and you can be more efficient with your money. Other recipe of distributed computing is you can scale horizontally. Talking about technology, by distributing your software, you get opportunity to have different data stores, different languages, and different technologies. The acid versus base, I think, is a biased conversation. Atomicity, consistency, isolation, and durability are good qualities to have in your software and your databases. By letting go of these properties, developers have to handle a lot more failure scenarios, and some of them can manifest in the worst possible. Folks, who's familiar with CAP theorem? So CAP theorem talks about the choice between consistency and availability in the presence of partition. In the absence of partition, you have to choose between latency and consistency. So the moment you go to a distributed system, you have to make these trade-offs whether there are failures or not. As I mentioned earlier, there are problems with duplication, duplicate messages, dropping of messages, auto messages. All of this have to be handled by programmers if they move to distributed world. I should watch this tech talk, a beautiful tech talk. Moment you have two different processes. When the messages are received from one to another, the receiving process is always operating on a past version. It is not operating on the concept of now. It is operating on the concept of then. This brings in a lot of philosophical and practical problems. Now, similar to data on the inside and data on the outside, there are significantly different problems to be handled at the design level. In the intra-process world, you focus on a lot of happy path scenarios when it comes to technology. In the inter-process world, you have to focus on a lot of failures. So the mindset that we programmers have to employ is different. So coming to the recommendation, distributedness for me is not an option. As systems become bigger, as the scale becomes bigger, you have to distribute your software. The choices, the questions are not about if, but where. So this talks about parts of the software communicating. Here, the dotted arrow represents inter-process communication, and the other arrow represents intra-process communication. So whenever you have to deal with scenarios, figure out what has to be intra-process and what has to be inter-process. Going back to the system metaphor, a fork and a spoon don't have much utility outside of dining. In the context of dining, a fork, a bowl, a spoon, a glass tumbler, all of them come together to form a system of elements. Human body is an example of, we have circulatory system. The arteries, veins, they all come together to form the circulatory system. The same thing for nervous system, digestive system, and muscular system. All of these come together to form a uber system, the human body system. So this is a system of elements. This is a system of systems. Now, most real-world systems actually are a combination of elements and systems. A car is an example where there is an engine, which is a system by itself. It might also have some trivial things like say microservices, which are not necessarily a system. I read this interesting article. Somebody wanted to build a Bugatti using Legos. They actually built it. A couple of key takeaways. The Lego Chiron has a top speed of 18 miles per hour, while the traditional 261. This gets to 60 miles per hour in 2.5. This never gets there, and so on. The point I want to make is, if your abstractions level are small, how far you go and how fast you go is seriously constrained. But because the Bugatti folks had engines built, they had higher level of abstractions built, the system they built is more reliable, more performant, and so on. The takeaway for software engineers is, there is this thought process of having a lot of small microservices. I'm fine with that. But in addition to it, you need to have coarser and higher granularity microservices. This is a thinking pattern I found missing in our community. So the recommendation here is, you should have coarser services or coarser or short services or APIs. All trees are DAGs, but all DAGs need not be trees. This is an example highlighting that. The figure on the left, on my left, is a tree. The figure on my right is a DAG but not a tree. I order food from Swiggy, I order food from Zomato. I order food from Toscano, I order food from Yoacha. Yoacha and Toscano both take services of the water and sewage board as well as Westcom. If you see this is an example of a DAG. All software that was built at Flipkart was meant to serve the use cases of Flipkart. AWS is an example of software which was built by Amazon, which was not necessarily meant for consumption within Amazon. So it need not go through the process of a search, checkout, order management for these services to be used. You can have Netflix using an AWS service, you can have Uber using an AWS service. So you can think of AWS is a headless system, while Flipkart's microservices are part of what I call a headed system. Folks, how many keys would you want a lock to be opened by? Few or many? Why? It would be defeating the purpose if it had too many keys. So keys are meant to be specific to a use case, a specific scenario. Here's another example. I guess most of you have played Tetris. The parts, these are called tetrominos. Tetrominos are meant to be composable and generic. You can compose different shapes by using tetrominos. Going back to the car example, a bolt used in a, say, a Honda car might be reusable in a Hyundai car. But I don't expect the door to be taken from a Honda car and put into a Hyundai car. There is place for both system-specific parts and generic parts. Going back to real-world examples, Flipkart has its microservices. Shopify has its services, I can have microservices. The Flipkart microservices are very specific to Flipkart scenario. Shopify services, they are not specific. They have a lot more generality built into them. Yeah, I want to talk about some of the developer to microservice ratio. At Salesforce, there was one service for 15,000 developers.
Service or microservice?
Microservice, basically it's a monolith. At Uber, the number of microservices is more than the number of developers. These are the extreme. I was part of a team in ads quality where approximately for 8 developers we had one microservice. So there are multiple flavors employed in the industry. So you can categorize this systems we build into multiple dimensions. Are they system of system or system of parts? Are they modular or not? Are they distributed or not? Are they headless or not? Are they generic or specific? This view of Flipkart was maybe a decade old, but you see there are different flavors of these employed in the industry. Yeah, so there is no single approach. You can have trade-offs with every approach. a judicious and nuanced approach to adoption of microservices are not is a key thinking process for us engineers. That is a takeaway I wanted to my last recommendation on this slide. I have a few minutes for questions. Yes, please.
Some of these choices are also based on how the direction of the company moves, right? Like, for instance,
It's a chicken and egg. Salesforce has been trying to move away from a monolith for years and they have not been. Now, I don't know if Shopify has chosen or they're stuck with a monolith. It is important that you make the right trade-offs. But I'm fairly sure wasting 6 hours on a build ever so frequently is not something Salesforce is having.
Sometimes it takes years to change the model. System is being implemented 4 or 5 years, partial requirement.
Oh yes.
Companies would have the resources and the cost benefit to buy that.
Look, I am very clear. It is not a question of if. It's a question of when and where you need to move to microservices. So it should not be premature, it should not be too late. That's a trade-off I was talking about.
Coming back to Convoy, we already had a very discussion over there. When we say that we should have the design teams and other things within an organization so that they can build a microservice kind of a structures and they can build solutions according to the teams which we have over there. What about we have some verticals as well, we have some horizontals which are related to the domain specific, but there are some things which are common to all, like security and all those things. Yeah. So how do these, because when these two things join itself, they are start making a somebody is enforcing one solution more into it, and other one is enforcing the product owners and architects. They always fight each other. Product owner want get the delivery done within the deadline, whereas the architect would be like, it's not secure or it's not network resilient and all those things. So,
look, as hard as these problems are, maybe these problems are preventing AI from doing their jobs. Jokes apart. Jokes apart. Look, there are many wrong ways of building software. There are few good ways of building software.
just wanted to understand one good way out of it.
No, I mean, it has to be very contextual. You have to understand a particular problem. I cannot give a solution. So, if you were to take away from my slide, my presentation, it is to use microservices or not. The answer is it depends. Your system is small, maybe one is sufficient. Maybe you may require only 2 microservices and not 100 microservices. I'm advocating that fine level of reasoning. The answer to your problem might be anything, again, it may be very nuanced and contextual.
In the last slide, you had headless and generic.
Yes.
How do you differentiate?
There is significant overlap. I would expect. There's a company called Fabric. Fabric builds software for checkout, but they're fairly domain specific. While your EBS, block storage, complete storage are more generic. But again, it's a very narrow distinction. All I'm saying is, you can build your software, you can segregate domain-specific parts and domain-agnostic parts. The more you have agnostic parts, the better it is for your system.
That would be headless.
You can be headed and still be built off generic parts. But if you're going to a header system, more of the higher correlation
if I need a strong consistency, I need to go to RDBMS, right? I know, for example, in case of Flipkart, right? So, are we really using, like, would they really use Sardine there to handle the scaling problems? In case of RDBMS, if I need a, say like, cut money there, right? I need some sort of strong consistency while doing some business transactions. So, do they really use Sardine there to scale up the systems? RDBMS Sardine?
I don't remember what was it, but I can tell you, Amazon used Oracle for a large part of their lifetime. So they are pioneers of microservices. They are the front runners in that perspective. But when it came to their own key systems, they used Oracle for a long, long time.
So when you said it's not a question of if but where.
When.
Would you probably also argue that it should also include the what? Because as we were discussing, this holds true for when you do transaction systems, when you have systems where the whole notion of service-driven concept really applies. Going back to your 2 by 2, when you have 4 quadrants, one of them is microservice. But what if I have domains or non-domains like security, analytics and stuff like that, but still do distributed systems, right? So they are modular distributed systems, but they don't follow the service concept at all. So they are not doing microservices. Where would you park them in your 2 by 2? Because what I'm understanding is the bottom half was not a good area to be in, right? Both are ball of marks, right? But what I'm trying to argue is, outside of this 2 by 2, there is an area which is not a microservice, but a modular distributed system. What would you call that?
A non-modular but distributed and not microservice.
Modular, distributed, not a microservice.
I'm not sure. That doesn't exist in my.
Okay. So let's say that you have, I'm trying to take the definition of the service conversation and then apply it. So microservice would typically, employ good for transactional systems like you were giving warehousing scenarios and all that. But when you are doing, let's say, traditional data processing, right, you still do data processing at scale in a distributed system, but they are not driven by the whole service concept. So what would you call that? That's one example. Okay. Security can be, for example, you are building different threat monitoring system. You are building a threat monitoring systems and there's 20 different kinds of checks you want to do. These are not services, right? These are not microservices, but they will have different modules, each module catering to a different kind of threat prevention or detection mechanism, running at a distributed scale.
If I had to put a finger, I would still use the word service, but not a microservice as works typically. It is not a business level decomposition, it is more infra level.
Yes, it is at an infra level. So you are applying service not from a technology sense, but more as a business service.
In that slide, I was talking about business level decomposition. The same principle that apply even at a non-business level. Further to what you are saying.
Got it. So they might not be called as microservices, but yeah, it's okay to call them business services.
Yes.
When you can distribute chocolates.
Yes.
Keep throwing them.
Yes.
You can pass.
Actually, my understanding is when we are building microservices, right, it's not about need of medicine right now. It's about what, because as a consultant, right, I'm hiring you and I'm showing my portfolio. You will realize that, oh, okay, still you are good in this, monolith or service oriented. But most of the organization we push toward microservices because seeing the future of agility in business to develop component or scale. That's why companies or enterprises being forced to adopt microservices. So seeing technical challenge and seeing the future of the business or company, it's a two different things. So when as a technical guy I will assess, then I realize no need. You are having this much of workload and and this much of a customer, still you're happily running this business about 3-5 years, right?
Okay.
So how business or leadership seeing a future of their product? Obviously, it is not needed right now, but because of their future sustainability, they are enforcing to adopt microservices.
Okay, folks. I want to go back to this particular slide. I'm saying being on top is non-negotiable. Being on the left or right is a choice you can make. And you have to figure out what subpart of a system that you need to make this distinction. Yes, microservice is the in thing. I gave an example of one microservice which had one method. It was invoking a Java API and returning feedback. So, where to apply distribution is, I'm saying, it is not a magic bullet. It has pros and cons. Take a judicious call when to use microservices or not. That is the whole premise of it.
And it also depends upon point of view. Right? In architecture, we see the viewpoint and point of view. Right? So, who you are and from where you are seeing, that is also makes sense.
Folks, on this trend, I wanted to include a bullet called politics. I did not. That is a whole different conversation. If your promotion depends upon you applying microservices, maybe you should.
Okay, in the interest of time, if you have more questions, you can connect with Naveen over coffee. Okay? Naveen. Thank you so much.
If they are okay to, we can ask them if they are okay to spend some more time. I don't know if you guys want to go to the restroom right now.
I'm happy to
We
answer.
have the next.
We have the next session in another 10 minutes after the coffee break. Yeah.
I have
If
one
you
last
guys are
question.
okay?
Yes.
So, since you know that every organization is going towards the microservice whenever they are getting a new requirement, but since now if you imagine Prime, right, they have just migrated from microservice to Monoliths to save the cost.
Somebody will raise this.
Yes.
Yeah, so are you also like seeing like in the industry, most of the companies are going to go, yeah, that I
No, I think bullet positive this point was this.
since we look at the Amazon and we just thought that let's continue on this microservices way, so are you also looking in the industry that they will again fall back to
Look,
microservices?
I'm saying there are business reasons to employ or not employ. There are people reasons to employ or not employ. There are many reasons to employ or not employ. The technical reasons to employ or not employ. Time reasons to employ or not employ. So if you take a grid of all of this, this is a multi-dimensional space. For some subset, it makes sense. For them, it does not.
You just start saying, when you say above, there's no subsets where this does not apply.
No, it came into my mind, but again, it's already too complex to talk about.
Very good, dialogue, and at least personally, I've seen after a couple of years somebody going into abstract and taking system thinking view and bringing it to software architecture. Very few people read that system thinking paper and book and all that, because that's a very relatively abstract concept, but still very nicely applies to architecture. When you started with systems of systems and elements, I was thinking of the jungle type conversation. So, have you read the paper around system thinking?
I have read books, but I have bad.
There's a very old paper, I think it's in 1954 or something that it came. So read that paper. It describes the same conversation using a jungle, the state of a jungle. So for example, when you have a jungle where there's a lot of antelopes, what happens? The jungle gets eroded. But the concept is that when you introduce wolves into the pack, the jungle actually increases. It's counterintuitive, but it helps you understand the whole system thinking process. It's a very nice research.
Okay. Thank you so much, Naveen, for sharing insights on the topic. Thank you.
Right, Naveen, you know the drill? Yes, sir.
Yeah, that one.